heat the crude oil for base of the crude oil, for characterization of crude oil, that is for paraffinic interior taking the charge. This is thermometer temperature sensor. This is stirrer, the flux temperature sensor. Then it is going to the column. From column, it is going to the refraction column, where it is going to the, where you are collecting the fractions. This is fraction cutter, and here you are, this is vacuum distillation unit, where we are transferring the charge of RCO. Here we are collecting the different fraction. Receiver, turntable. So here we are receiving soil. This is vacuum pump. The vacuum pump is applying the pressure to the whole system, and this is. But in our lab, we are doing the manual distillation. This is TVP manual, and then TVP or vacuum distillation. You see, now we have made the cut. Generally, it's heavy, so the yield of 0 IBP to 50 degree C is negative traces. That's why we made the first cut 0 to 100 degree C. Percent volume, density, specific gravity, and API gravity. And density of crude is 0.8775. Clear? So now we are making other cuts. We are making feature here. 409 will be the temperature of
4%.
79. Up to here, this is up to here is the 370. Then you are extrapolating. This is 379. This RCO. So now the 370 to 400, 400 to 450, 450 to 475. Say you want to collect the 370, 400 cut. Correct?
Yes.
From this graph, you can find out the percent volume.
Yeah.
How much will be the yield of percent volume of 370 to 400 cut? Is it blue line is percent weight, and this is a graph from IBP to 550 degrees C. IBP to 550 degrees C, and this graph is being used to find out the yield of any fraction of crude.
So don't we in some cases need to have a swing cuts or a cuts that have overlaps to determine the best feed for stock for hydrocrackers, for example, or low oil?
ASTM is having in between IIP and TBP, and this one divided by 2. For 195, you add this one and this one divided by 2. So that will come your mid volume percent. So this is your mid volume percent. This is volume percent. Again, using that formula, you will convert this rate percent into volume percent. If you are having volume percent, you have to convert volume percent into the base percent. Then find out the density, find out the API gravity, find out the pore point. This is the wax content. Now you see this number. The wax content is, this fraction is 39.2. 437, 44%. 454, 45. And this is having the highest wax content, 48.9. So what you will do, you take the fraction 450 to 500, where the maximum wax content is there. So you remove this wax content and pour back with these fractions. So you will get a dewaxed gas oil, and that dewaxed gas oil can be used as a feed for bright stock for lubricating oil. The congealing point, sulfur total, kinematic viscosity 70 and 100 degrees C, and then carbon residue, and this is Watson characterization factor. You see, because of the wax content, all these fractions are paraffinic base. High AUP. This is your mid-weight percent. Mid-weight percent versus percentage weight sulfur. you can find out the sulfur content of any fraction, any mid-weight percent of crude. Mid-weight percent total sulfur. Suppose 0.25, 0.25 will cut over here, then mid-weight percent over here. This is the total sulfur. We draw the graph and we can find out the sulfur content of any mid-weight percent. Now we are doing the density. The properties we are determining for the crude is density, weight to volume versus vice versa calculation, checking the consistency of crude oil. This is the significance, control of refinery operation used in various correlation, char factor, NDM method, diesel index, NMR, etc. also gives a rough indication of type of crude oil, mass upon volume, you know density, this is specific gravity and this is API gravity. Now density is being determined using these instruments, hypnometer, density motor, hydrometer and oscillating U-tube method. Oscillating U-tube method is now an automatic densitometer where simply you take the temperature and inject the sample, you directly get the density. Oscillating U-tube, repeatability, transparent, middle distillate 0.2 kg per meter cube, crude oil and other petroleum 0.4 kg per meter cube, reproducibility 0.5 kg per meter cube and 1.5 kg per meter cube. What is the difference between the repeatability and reproducibility? In all the methods, you will find these words.
I think it's the range of accepted strongly variation in reading during repeating the same experiments. The accepted range for the
From 31 to 47, XIF 5 kg per centimeter square. Light and analysis carried out by GLC actually gives the percentage of the hydrocarbon distribution, which I have already discussed of the assessing the LPG potential of the crude oil. Distillation D86 already discussed. 100 ml sample, distillation rate is controlled, data getting converting into the AET, and residue is the flask, and loss is the difference between the volume collected and total volume. Is the loss, and residue left in the minus R 10 RVP. Kilogram per centimeter of unburned hydrocarbons. If your products of incomplete combustion, this explains the need to limit the FBP centigrade or be up to the 45 degree centigrade. If the liquid is not flowing at that temperature you add, and you can report the 760 hydrocarbon affect the color. If it is colored. If it is colored, then you do the de-resinified. For de-resinified, what you will do, you dissolve all the sample in the normal heptane and pass through the gel, Fuller's earth. When you will pass through the Fuller's earth, all the hydrocarbon and wax will come as a colorless portion. Color will be absorbed by the Fuller's earth. Correct? Then you add the ether and alcohol blend of 50 to 50. Shake well, you do the chilling and then filter it at minus 20 degree centigrade. You will get the precipitate of the wax over filter. Collect the wax by dissolving in acetone and then evaporate the acetone. Then take the weight difference of the flask is the wax filter. Clear? Yes. Tell me what is clear.